Welcome C peeps, my name is Divesh Thakker. Okay, first of all, I'm gonna call all you competitive programming experts as C peeps. So welcome to the channel Learn Competitive Programming with CodeChef. Now if you're interested in competitive programming or want to master data structures and algorithms, this is the one-stop destination for you. Before we get going, if you haven't already subscribed, do hit the subscribe button and let's get started. So our agenda for today is going to be, we're going to walk through the problem statement, then we're going to look at our approach, we would understand as to how our solution is working, we'll analyze our solution, and finally we'll get our hands dirty and we'll start writing some code. Alright, so now let's look at the problem statement and let's see what we have in store. Essentially, Chef and his little brother are playing a game of sticks. Now what's a game of sticks? The game says we need to pick 4 sticks such that the rectangle formed by those 4 sticks, the area of that rectangle formed is maximum. So basically I have been given n sticks, I will be given n sticks, and I will also be given an array which denotes the sizes of each particular stick. Right, so I have been given n, the number of sticks. I have also been given the size of each stick, and what I need to do is I need to pick 4 sticks such that the area of the rectangle formed by combining those 4 sticks is the maximum, right? So the chef's brother has already done this. We need to figure this out as well. So yeah, that's what is given over here. If you go through this, the input will be t, again showing as the test cases, and then I'm being given 1 n, and then I've been given an n space separated integer array. Now that is the size array which we have. Simple output, you just need to denote the give the maximum area, what you can make out of the sticks, what you have selected. Okay, now if you look closely, this is an optimization problem, right? This basically wants you to find the maximum area. You need to maximize the area of the rectangle which is formed. So one thing pops up in my mind is greedy approach, right? And yes, that's right, we're going to look at that later. This is the constraints. I have 100 test cases. The length of the stick cannot exceed 10 raised to 3, and even the number of sticks cannot exceed 10 to the power 3. Okay, let's brush up through this, what it is given as an example. Here I have 2 test cases. The first test case contains 5 sticks, so I have 5 sticks. These are the length of those 5 sticks. Essentially, I have been given 2 sticks with length 1, I have been given 2 sticks with length 2, and 3 is the length of 1 stick. Can you form a rectangle with different lengths as your breadth and different lengths as your length? Not possible, right? So basically opposite sides of a rectangle should be equal. That here means that I need to choose 2 sticks which are equal in length for my breadth and my length, right? That is very important, and that's what is giving me -1 over here, if you see, because I have 2 sticks of length 2, but I don't have any equal sticks for my length or breadth, whatever you can say. So here I cannot, it is not possible for me to form a rectangle out of 4 sticks. If you have a rectangle here, so my answer is -1. In this case, I can form a rectangle by 1 and 1 to my length and 2 and 2 to my breadth, or vice versa. So 1 into 2 is 2, and that is the maximum area I can get out of this test case. And again, so first of all, our problem says that you cannot break a particular stick, right? So you need to use your stick as a whole. If you want to use it, you can take it or you don't. So it's either a 1 or a 0. There's no fraction. Another thing, what implicitly my problem also states is that I can use only 4 sticks to form my rectangle. That is, I cannot use 2 sticks to combine 2 sticks and form a side. I only need to use 1 stick per side. That's what it states as well. Now I went to Mr. Greedy, our algorithm, and I told him, okay, I have a problem. This problem states that I need to maximize the area of the rectangle. Mr. Greedy told, okay, basically you mean to say that you need to maximize the lengths of the sticks which you would be using to form this particular rectangle, right? I said, yeah. So that's what Mr. Greedy says. Our greedy algorithm says, or we're going to use greedy in the sense that we need to maximize the length of the sticks which we would be using to form our area. Okay, so now let us look at our approach as to how we will be solving this problem. Basically, I've been given my array over here. The size of the array is 10. This is the length of all the sticks which I have been given, and I need to find the maximum area of the rectangle so formed. Now one way to do this is by sorting this array and getting the area to be maximum by getting the longest length of the sticks. But again, I don't want to sort this. Can you have another approach without sorting the array? Well, you have one. Basically what we are going to do in this approach is we're going to create a new array, which is the frequency array, and that array will keep a count as to how many times a particular stick occurs. Now we're going to denote a stick with equal length to be 1, right? So say for example, I have in this case 2 sticks with length 6. If you can track over here, 2 sticks with length 6, right? So I will group them together. I will find how many times a stick with length x has occurred in my end array, right? Here the length x is 6, so I'm going to see how many times a stick with length 6 has, as to how many sticks with length 6 do I have. And how do I put it in my frequency array? Now first question is, why this 1001? Basically, if you see the constraints, the maximum length a particular stick can have is 10 to the power 3, right? And that is the reason I've taken this array. Why? Because I'm going to denote the length of the stick to the particular index where we are storing it in the frequency array. I didn't understand that. Don't worry. What I mean to say is, I will take a stick, I'll look at the length, and as I told you before, I'm going to group sticks with on the basis of length, right? So I'm going to take the stick's length and I'm going to put it in that particular index of my frequency array. So here I have this stick of length 6, so I'm going to go to my 6th index and then I'm going to increment my count by 1. That's what I'm going to do. If we look through this, I have 1, this will become 1. When I'm going forward, I have the length 1, move on to the first index, increment it by 1. So this frequency array means that for a particular index I, the value of I is the length of the stick, and the value inside my frequency array at position I is the frequency as to how many times that stick we have in our bunch of n sticks, right? Now what I want is, basically, if I have 2 sticks, I can get the lengths, and if I have more than 2 sticks, I have 4 sticks, I can get the length as well as breadth. The most important thing to understand this problem is a rectangle is a square. What? I know that, right? But this is what most people miss out. You want to consider a number which has occurred 4 times, and if it is that is the maximum number, I will form a square out of it, right? Because I have 4 sticks, I can form a square out of that. And that square is going to have the maximum area even greater than the rectangle which you can form, the next rectangle which you can form. So a square is a rectangle, that's what I'm going to remember, and I'm going to move forward. Whenever I see, okay, so first of all, I'm going to loop in through and I'm going to see the maximum number which I have, because this essentially has the maximum number, right? This array is going to go on till 1001. This is not going to stop over here, but essentially here I just have the maximum element to be 6. So after this, I'm not going to have any number, everything is going to be 0. Simple reason is 6 is the maximum length I've been given. So I will loop in from the end. What I will do is, I'll just check from the end, because the end has the highest length of the stick. What I'm going to do is, I'm going to loop through and I'm going to check the frequency. If I have a frequency of equal to 2, I can make it as my length or breadth, whatever you can say. I can make it as one side, a pair of side. So I'm going to choose that because that is the biggest I can get. Looping forward, I can go ahead. For a square, if you have the length as 4, what I can do is, I can decrement the count by 2. So say for example, a 6 here was 4. What I can do is 4 minus 2 and check again if it is equal to 2. If it is, then I have a square in store. Don't worry, we're going to look at it now. Okay, so now let's start off. Basically, I'm going to have my area I as 9 because I'm going to loop in through back, right? This is my area. I'm going to denote it as 1 because I'm going to multiply the I value which I have from my frequency, and this is my flag. I'll set it to false now. Oops. Yeah. Alright. So now let's assume that we have already done all those, but I'm going to start from the okay, I'm going to start from 1001 because I want to start from the biggest length what I have for my stick, and then I'm going to loop in. Okay, so I'm going to do a I minus minus, but I have already looped through it. As you know, it is 0 for this example. So let's say we reached here. This is the 9th index. For the 9th index, I don't have anything. 0. I move ahead. I go to the 8th index, and then I go to the 7th index. I don't have anything. Now, till now I don't have anything. Now a pointer, this is my I pointer, moves to the 6th index, right? So the value of I becomes 6. Now I have the value greater than or equal to 2. If it is less than 2, I'm not interested because I cannot form even one pair of side from it. The value is 2. Wow, that is good. I got my first element. The value of I, remember, is the length of that stick. What I'm going to do is multiply it with my area. Essentially, I'm going to multiply it with I. The value of I over here is 6. 1 into 6 becomes 6, and that is your area now, right? This flag is also very important at this stage. If you look closely, I have already multiplied once. I have already found out one side. So what I will do is I will make this thing as, I'll make this thing as true. My flag is true now. So now what I will look for is only once. Only once I need the side pair. If I found that, I will then end my program because I found the area. I don't need to do L into B into C into D, no, right? Because this is a rectangle. Moving forward, before moving forward the square condition, what I will do is I will reduce this frequency by 2 and check if it is 2. If it is 2 or greater than 2, which means that yes, we can have a square, I will multiply it by I again. Now here, this is not the condition, just a second, yeah. Here this is not a condition, but yes, that is what will happen when you have a square. Okay, so now let's going forward, 1, 0. What do you think? Should I take an I over here? You've guessed it right, the answer is no, because I is 1. The frequency is 1, sorry, not the I. The I is over here 0, 1, 2, 3, 4. The length of the stick at this particular frequency is 4. But the frequency is 1. I have only one stick with length 4. I cannot do anything with it. I cannot create even one pair of side. This is rejected. My pointer moves forward. Yes, I have another one with greater than or equal to 2. This one is 0, 1, 2, 3. So the length of the stick is 3. So I have 3 sticks with length 3. Yes, I can do that. The value of I is 3. And I'm going to multiply 6 and 3, which forms 80. Okay. My question to you is, let the flag be as it is. My question to you is, do I need to end this program? Yes, absolutely, because I found out my area. Remember I told you we are starting from the extreme right, and that is the maximum distance, that is the maximum length of the sticks, right? So when I found the maximum area, this is what I have as my maximum area. So I can break my array. Now let's look at one more example. This is what I have been given, and this is a bit different, okay? Again, this is my frequency area. This goes all up till 1001, and we got a pointer a bit closer now, okay? So now this is what I have in my array. I have 1 appearing once, I have 2 appearing once, I have 3 appearing thrice, and again 4 appearing once, and that's what I have. So let's continue with the zeros, and I've reached over here. This is 0, 1, 2, 3, 4. So the value of I is 4. Now the frequency is 1. Can I take 1? No, 1 is not possible. Moving forward, the value is 3. Yes, it is possible. The value of I is 3, and yes, I can take this as my side, and since this is the greatest, what I will do is I'll just do 1 into 3, which is 3, right? Moving forward, I becomes 1, I's value is 2, the frequency is 1 for 2, just a second here. So the frequency with stick of length 2 is 1, I can't take it. Moving forward, the frequency of stick with length 1 is also 1, and I don't want frequency of 1, I need it greater than or equal to 2. I move forward, this frequency width of stick 0 is 0, and that's going to be 0, of course, and that ends, right? So my if condition, the middle condition of my if statement ends, and I have left out with my area 3. Should I print the area as 3? No. I have not looked at the flag, but essentially my flag was false, which became true. So in the end, that's why I took this example to explain that in the end what we will do is we will check my flag is false or not, right? If my flag is false, then I can print it. But again, you will say, okay, if my flag is false, what if I have not multiplied my area even once, right? So we need to check for area equal to 1 as well. So essentially, this flag says that I've only multiplied once, I've only got one pair of sides, and therefore my answer would be -1, as you would expect. So these are a couple of examples, guys. I hope you get the intuition. Okay, so after discussing the solution, now let's convert it into code. I'm creating my scanner class. Yeah, so I'm going to use Java over here. If you're not aware of Java, it's even better because you're going to learn a new programming language. It's going to be plain simple Java, very similar to C++. So this is our input. The scanner will take in our input. Let's scan in my integer for t, which is the test cases. So I'll create new integer t. For my test cases, I'll just say scan dot next int. This takes in my integer t while t approaches 0. What I will do is I'll create a new integer n. Now n is the number of sticks we have, right? So I'll just say scan dot next int. This is the number of sticks we have. Now let's take in the array which we have been given, the length of each particular stick. So I'll just say for int I equals to 0, I less than n, I plus plus. What I will do is, okay, first of all, I've not created my array. So let me initialize my array first. So I'll just say int array arr equals to new int array of size n. So that is my array which I've initialized. Now at ith position of my array, can you please take in the new integer? So I'll just say scan dot next int. Alright, so this essentially will scan my input what I've been given and add it to my array arr. So I've created that array. Now let's create the frequency array which we had thought of size 1001. So I'll just gonna say int array frequency equals to new int array of 1001. I've created my frequency array. Now let's fill it. So I'll loop it again. I will loop my n array arr which I've been given, and let's see how I'm going to do it. So I'll just say int I equals to 0, I less than n, I plus plus. Now I less than n, right? I'm looping through my given array. Why? Because what I'm doing is I'm taking the length of each particular stick and I'm adding it to the corresponding index. So the index of my frequency array is the length of the stick. That's how I'm relating both these arrays. That's my relation between both these arrays, right? So in my frequency array, which index I am placing? The index where I'm placing is my array of I, right? That is the length of the stick. So I'll just say array of I. Now that is the index where I'm placing, right? And yeah, I am incrementing it with 1, right? I'm incrementing the count every time with 1. And that is pretty much it. That's as simple as that. So this essentially will fill my frequency array with the correct frequencies of each particular stick of a corresponding length. Okay, so now I have this array. What next we can do is we can just start off with our main loop. So what I will do is I will say for int I equals to, now this will be at the end of my frequency array, right? Because as you remember, I'm going to take the stick with the maximum length and I'm going to find the frequency, and I'm going to start that like that. So I'm just say frequency array dot length minus 1, I greater than equals to 0, I plus plus. Okay, I greater than equal to 0, I plus, oops, sorry, I'm gonna run a reverse loop. Minus works for here. So now let's start with the basic condition. If array of I, the frequency of I is greater than equal to 2. Now what this does, if my it's simple, right? We've already discussed. If my frequency is greater than 2, then I'm going to include this stuff, right? So I'm going to say area. Where is the multiply? Multiply equal to I. What is I? I is the length of the stick which we had. I here is my frequency length index, right? It is the index of my frequency length. So that is the essentially the index of my frequency length array is the length of the stick which I have. So I'm going to increment, I'm going to multiply my area with I. And again, if you remember, I don't have my area. Okay, let's just create that first. So I'll just say area equals to 1, and I need to initialize it with 1, not 0, right? Because we are multiplying. After this, what I need to say is I need to create a new flag, and the flag which we had, right? So that is essentially going to keep track as to I've found one side, I just need to find the other and essentially break in when required, right? So this is our first condition, so I'll just say flag as true. Okay, and now, okay, I've set my flag to be true, I've set my area. Now I need to check for the square condition. So basically how I'm going to do this, essentially I'm just going to say that the frequency of the ith position, I'm going to decrement it by 2, right? So I'm going to decrement the frequency at the ith position by 2. Why? You'll come to know later. And yeah, I think that is it. And yeah, we need to put it into another if condition here, because we have introduced the flag. So I'll just say that if my flag is false, oops, yeah, only then I need to do this, right? So let's just indent this. Alright, so if my flag is false, which means when my flag will be false, when I'm entering for the first time, when I'm getting my first pair of sides, when my area is 1 by default while initialized. So that is the condition where I'm checking. That is the condition where I will decrease the frequency by 2, because if it is 4 or greater than 4, I need to check if it is so. If it is, then it will run again. So I have not checked it now, we're going to check it. Now I'll just say that if flag, this essentially is checking, just a second, yeah, this essentially is checking that okay, now once you have already got a particular pair of side, now simply I need to check if it is greater than equal to 2. So I'll just say it's the same frequency of I is greater than equal to 2. If my frequency of I is greater than equal to 2, again do the same thing, area, I'll multiply it by I, right? The same drill. Then I'll set my flag to be false. Now why I'm setting it to be false? I could have kept it true because I'm obviously going to break out, because we know that this is the second time we are filling the rectangle's area, so no need to continue further. So we can just break out. But yeah, I'll just tell you why I took it as false, right? Because when we will be giving the final output, I guess it is it. We just need to print the output now. Yeah, I have my frequency greater than equal to 2, I'm putting in my area, I'm setting my flag, I'm reducing the frequency. Now this is just for, okay, now why did I not take an else statement here? I could have taken that. No. If you take the else statement, you miss out on the square part, because if I'm entering once, the first time when I'm entering this particular if loop, for the first time I'm entering it, I am setting the flag to be true so that I can enter in that same particular value of I again by decreasing the frequency by 2 and checking if a square condition is occurring or not. If it is occurring, then this would take care of that as well, right? And once it enters this flag is true, then okay, the flag is true, need not necessarily it's going to enter the very same loop. It's going to reduce I, and then it's going to again enter, and when this time it enters, it's surely going to break. So it's just 2 times I'm entering these if loops, right? So finally, so now let's just say that if I have my flag to be false. Now my flag is false. When I have my flag false, right? When my I have not entered the second loop, the if condition. When I have not entered the if condition, it is only then my flag will be false, right? So here I'm going to say system.out.println. I'm just going to print in my area, right? Because here I have successfully put in 2 values into my area, so I'm just going to simply say area, else print -1. Right, and this is pretty much it. This wraps up our code for this problem. So yeah, that's what we have. Finally, we are let's try to submit it and see what we have. Alright, so finally I'm happy we have cracked this problem. Let's look at the solution. Hopefully, let's keep our fingers crossed. I'm sorry, we have a compiler error. Just a second. Let's have a look. I think I have a typo. I thought of that. Okay, yeah. Performer line 22. I just missed up the square bracket. Okay, so till now our code looks good. But take a condition. What if no two sticks have equal lengths? In that case scenario, my flag will remain to be false, right? Because it cannot enter this particular if loop when I don't have my frequency greater than or equal to 2. Again, if it hasn't entered this, it cannot enter this because my flag will remain false. At the end of the day, I will have my area being printed, which is the initial value, in that case -1. I've taken an example over here to demonstrate this. So to overcome this small problem, what you need to do is we need to create a new boolean. So I'll create a new boolean here. I've created boolean is done is false, and then what I'm doing is I need to say is done is true over here. So I've removed the earlier boolean which was flag. I'm not using flag now. What I will do is I'll create a new boolean. So whenever I'm entering into this if statement, that is when I need to print the area. So instead of using the flag, what I will say is, okay, if it is done, then you need to print the area. If it is not so, then you need to print -1. So that is how our flow will be. Okay, so let's go on to submit the solution now. So finally, we have hit the AC